Okay. So you got your final, huh? First of all, you're gonna be okay. You're gonna be fine. You already learned all of this. You just have to recall it. It's somewhere in your brain. You just have to trust. I put a bunch of definitions here that are the important definitions for you to know. If you read this definition list and you see something you don't know, look it up. It is either in your notes, but looking through your notes might be kind of a nightmare because we don't organize that much. Look it up. Make sure you type in math definition because some of them it might be a little wacky. Let's get started. If also you're in luck. If you're watching this, I'm going to reward you. I'm going to tell you exactly what'll be on the final, exactly what type of questions. I'm going to circle which ones are almost word for word. That way you have a better focus. A, it's not on the final, but let's do it anyways. It says decided the two shapes are similar or not. They are similar if the ratios of the corresponding sides are equal. In math terms, what this means is they are similar if 20 divided by 16 is equal to 10 divided by 8. Let's take out my calculator. I'm going to use my phone for now. 20 divided by 16 is 1.25. 10 divided by 8 is 1.25. The ratios are the same, therefore they are similar. B, and yes, 7th period noticed, no one else noticed. A, B, D, get over it, it's fine. B, if a rectangular football field has an area of 650 feet squared, and the scale factor of k equals 2 divided by 5 is applied, what would the area of the new rectangular field be? Round your answer to the nearest whole number. So this is my pre-image. And if I want to know my new one, again, that's my image. I'm going to use the formula that you learned in Unit 1. And again, the posters will be there. It's area, because I want area. Therefore, I'm going to use the formula pre-image times k squared equals image. Therefore, 650 feet squared times 2 over 5 squared equals my new area. First, I got to evaluate what's 2 over 5. So that's 2 divided by 5 is 0.4. So I do 650 times 0.4 quantity squared will give me my new one. Next, I have to find out what 0.4 squared is. So 0.4 squared is 0.16. So 650 times 0.16 equals new one. So I take my 0.16, multiply by 650, 104. My units, feet squared. Okay, if a cereal box is scaled up by a scale factor of k being 4 over 3, which is 4 divided by 3, and a new volume of 300 inches cubed, what was the original volume of the cereal box? Round to the nearest whole number. Right, my new volume is 300 inches cubed. So, sorry, let me write down the left side. I'm going to use the formula pre-image, it's volume. I use pre-image times k cubed will give me my new image. So I don't know my pre-image. My scale factor is 4/3. And I don't know my preimage. Therefore, I'm going to use a placeholder. Use x. X times 4/3 cubed equals 300 inches. First, I need to figure out what this is. So 4 divided by 3 is 1.33333. I'm going to cube it. So cubed. So I have x times 2.37 equals 300 inches cubed. Now I solve for x. How do I undo multiplication? Divide by 2.37 on each side. So 300 divided by 2.37. My old volume was 127 inches cubed. Now, part D, there will be a volume question on the final, but it will not be finding any of the originals. What it will be is it's going to be a shape. It's going to be a three-dimensional shape. You're going to get one side length. So let's say it's, let's say it's a pyramid. It's not a pyramid, so don't freak out. I'm going to give you the side length of, let's say, 7. And it's going to be scaled up. And I want to find the new volume. So you have to find the original volume first. And I'm going to give you the formula for that shape. And you're going to find the new volume. So there's going to be different ways to solve the problem, basically. Okay, let's move on. Unit 2. You're going to sketch the function. You're going to label the vertex and describe the transformations. Function transformations. So every function transformation has the form a times f of x minus h plus k. In this case, it's a quadratic, so I'm going to write the general form of a quadratic transformation. A, there's a negative sign in the a spot, so a is -1. H, again, h switches signs. So if I see x plus 2, h is -2. K plus k, so then what I see is what I get. -6. A being -1 means there was a reflection across x-axis. By the way, the final, actually, let me take a look at it. Okay, the final, it's a combination of B and C. So you're going to have a graph, you have to find the function, you have to give me the vertex, and then write the transformations. So I don't know which one you find easier, but you'll be given like C and be asked for the new function, the vertex, and to describe the transformations. Okay, h being -2 means horizontal translation left 2 units. K equals -6 means vertical translation, so ht is horizontal translation. Vt equals vertical translation. So there was a vertical translation down 6 units. Our vertex is given to us by hk. So our vertex is hk, which means our vertex is at -2, -6. When we do our sketch, and it is just a sketch, my vertex is at -2, -6. So -2, -6. It's here. It's the only points that I need on the graph. And then reflection across the x-axis means it's going to go from looking up to looking down. And therefore, that is my sketch. So I sketched it. I'm going to label the vertex. And I describe the transformations. Okay, the next one. What's the parent function? Absolute value. Therefore, it's a absolute value x minus h plus k. A equals 1 means no reflection. H minus 7 minus h, so h is 7. Horizontal translation right 7. K equals 2 means vertical translation up 2. My vertex hk, therefore it is at 7 comma 2. Let's sketch it. It's at 7 comma 2. There was no reflection, so it's still going to point up. Sorry. Your final will look like a combination of B and C. Now to find the equation of the transformed function, first you have to find where the vertex is. The vertex is at 3, -2. What type of function is the parent function? It's a quadratic. So it better have an exponent of 2 somewhere in your function. Again, you're just going to plug it in to your general form, which is a times x minus h squared plus k. A, there's no reflection. A equals 1. H is the x coordinate of the vertex, so h is 3. K is -2. So you plug in your h and k values. So I got 1 times x minus 3 plus -2 is -2. And then what y'all forget, and I pretended to forget, was the square. That's it for Unit 2. I'm not going to ask you to find key features, although trust me, I really wanted to. Very quickly, let's do D, which is an absolute value one. The priority in Math 2 was quadratics and absolute value functions. So the parent function is absolute value of x, meaning the transformed function will have a times x minus h plus k. So I have to find out what a, h, and k are. The transformed function will always be the solid line. The parent function will always go to the origin, no matter what. This is now pointing down, therefore a is -1. There was a reflection. It went left 2 units, so h is -2. If it helps, write down your vertex first. Okay, it's 5. I'm going to substitute these values back into the equation. -1 absolute value x minus -2. When you subtract a -2, you can think of this as -1 times -2. Negative times a negative, positive. That is why when you subtract a negative, you get a positive. So x plus 2 plus 5. Now the fun stuff. Quadratics will be the majority of your final. There will be a question exactly like A and B on the final. There will be a question exactly like C on the final. And there will be a question exactly like the 2 examples on the back. Find the factored form by factoring. This is the part where you don't freak out and you think back. Well, what is factoring? Factoring, we're using the X and the box method. We have to factor. Given it's in standard form, I find ABC. A is -2. Sorry, standard form is ax squared plus bx plus c. So when I find ABC, I'm only looking at the coefficients. B is -11. C is -9. Now, one thing about this problem and this problem. You have potential for different answers because I am not asking you to take the greatest common factor out first. This one had a greatest common factor of -1. I could have taken a -1 out of all of this, and then everyone would get the same answer. But I want you to be flexible. So I'm trying to do it the way I assume a lot of you will do it. A times C goes up top, B goes in the bottom. Therefore, -2 times -9 is 18. B is -11. I have to then solve for these. We'll multiply to positive 18, but add just -11. -2, -9. Next, I go to my box. Top left, I get the first term. So ax squared goes there. Bottom right box goes C. The remaining boxes, in whatever order you want, go to your two solutions that you got in your diamond. -2, -9. Next, to solve the box, your first step, look at your first term. What are your possible factors of this? So if you look at -2, the only factors are 2 and 1. Therefore, one of these has to be 2x, one of these has to be 1x. If I put a 2 here, 2 times what equals 9? 4.5. Well, that's not nice. So what I'm going to do is I'm going to put the 2 here. I'm going to put a 1x here. Now I need to check. Does 2x times 1x equal -2x squared? Well, no, I need a negative. So one of these needs to be negative. It does not matter which one. It does not matter. And this is where you might get different answers, because at the start we should have factored out a -1. Now the standard mentions nothing about greatest common factor, so I will not test you on that. I will choose this. Now you gotta ask -2x times what? Sorry, forgive me. Please don't hate me. -2x times what is -2x? Well, that's just 1. And 1x times what equals -9x? It's -9. Double check. 1 times -9 equals -9. We're good. So then your factors are x plus 1 times -2x minus 9. You might also get -x minus 1 times 2x minus plus 9. Or you might get -1 x plus 1 2x plus 9. So these are the three forms you might get. On the next one, I'm going to factor out the greatest common factor because I want you to get to that point. We might just not be there. -4x squared minus 60x minus 200. Well, 4 divides all of these three numbers evenly, so I will take out a -4. Because the first term is negative, therefore I will remove a -4. So factor out a -4 and rewrite it. -4x squared divided by -4 is just x squared. -60x divided by -4 plus 15x. Negative 200 divided by negative 4 plus 50. Now I'm left with negative 4. I don't know why I was going to rewrite it. ABC. A is 1, B is 15, C is 50. Therefore, what multiplies to 50 but adds to 15? 10 and 5. There was one other thing I taught. When A equals 1, you don't need the box. These answers give you your factors. But I cannot ignore that negative 4 that I factored at the start. So my answer is g of x negative 4 times x plus 10 times x plus 5. The next problem that will definitely be on the test. Complete the square. Find the vertex form by completing the square. Okay, first step I said, you're going to group the first two terms. Next, you find your magical value. Your magical value is what you are going to add and subtract. Now, what we're doing is we're changing the form. You change the form of something by adding 0 or multiplying by 1. In this case, we want to add by 0. To do that, you create a perfect square using your first two terms. Your magical number that you will add and subtract is b over 2 quantity squared. B is 12. Quantity squared. 12 over 2 is 6 squared. So this is 36. So my magical number is plus 36 minus 36. And again, the idea behind adding 36 and subtracting 36 is you really just added 0. You didn't change what this is. You simply changed what it looks like. And why we do that is to create a perfect square. This, if you were to factor it, just these three terms. If you are to factor these three terms, it becomes x plus 6 squared. Negative 24 minus 36 is negative 60. And now you're just looking at vertex again. Vertex is HK, meaning your vertex is at negative 6, negative 60. Do not trust your x. It is the opposite of what you see. On this one, I'm only going to do one of them. A toy rocket is launched and its height in meters after t seconds is given by the equation h of t is negative 4t squared plus 16t. After how many seconds does the rocket reach its max height? What is the maximum height the rocket reaches? After how many seconds does the rocket land on the ground? I will be honest with you. The final question looks a lot more like E. But I want to challenge you. Sorry. Oh no. Let's look at this problem. After how many seconds does a rocket reach its max height? I'm going to draw a very rough sketch at first so you see what's going on. Now, when you're doing this sketch, it might start off rough. Basically, the path of the rocket will look something like that. It starts on the ground, so I know it's here. The x is seconds, and the y is height. After how many seconds did the rocket reach its max height? It means I have to solve what this is. Well, what is that? It's the vertex. What is the max height the rocket reaches? Well, that's the y value of the vertex. After how many seconds was the x value of the vertex? The max height is the y value of the vertex. After how many seconds does a rocket land on the ground? Well, where on this path does the rocket reach the ground again? This is the starting point where it's on the ground. When does it hit the ground again? Here. What is this called? It's the x-intercept. Which means I need to solve for the vertex and I need to solve for the x-intercept. If you get a question that asks you about initial cost or weekly operation cost or something of that nature, that would be your y-intercept. You don't need to solve for the y-intercept here, because you can assume 0 seconds on the ground, 0, 0. You can already solve for your first x-intercept and your y-intercept before you even do any math. Granted, analyzing is math, but you didn't do anything scary. The order I would solve this in is factoring first. Now, we could do the whole ABC, go through the motions of factoring quadratics using ABC, or you can use the skill of factoring out the greatest common factor. And if you can factor out the greatest common factor, you will see that this problem is a lot more simple than factoring the whole entire quadratic. So here, the greatest common factor I can take out a 4 from both, and they both share a t. The first term is negative, so I should factor out negative 4t. So h of t equals negative 4t, and then what's left over is t minus 4. And now, if you can tell, there's nothing left to factor. There's no more quadratic anymore. We factored the quadratic. My x-intercepts I solve by setting each factor equal to 0. So here, if I want to solve for t, I divide both sides by negative 4. My first x-intercept will happen at t equals 0. That verifies my initial analysis. And then here, plus 4, plus 4. T equals 4. Therefore, my second intercept happens at 4, 0. Again, this is a root. This is the x-intercept. 4, 0. And what does this represent? After how many seconds does the rocket land on the ground? Well, after 4 seconds. After how many seconds did the rocket reach its max height? I have to solve here. What is this value? The vertex always happens in the middle of both x-intercepts. So what's in between 0 and 4? 2. If it's a question that's not as easy as what's in the middle of 4 and 2, then you add your two x-intercepts, divide by 2, so that's 2. Then you take this value, you take one of your x-intercepts, you do 4 minus 2, and that's 2. So you check that the distance, that this is equal distance. It is not just 2 because of 0 and 4 are 2, and we divide by 2. It is 2 because that is what makes this point equidistant to 0 and equidistant to 4. Equidistant meaning it's the same distance. It's an equal distance. So I know that after how many seconds does the rocket reach its maximum height is 2 seconds. Another thing you can do is complete the square. But for a question like this, you didn't need to complete the square. That flexibility is what I'm trying to get you to reach. We're not all the way there, and you're a sophomore, and it's okay. You might not reach that level yet. But reaching flexibility is the ideal point. What's the maximum height the rocket reaches? Well, if it reaches it at 2 seconds, and that's my independent variable, I'm going to take the independent variable and substitute it into my original function. Meaning h of 2 is negative 4 times 2 squared plus 16 times 2. 2 squared, PEMDAS, we cannot forget PEMDAS, is 4. So negative 4 times 4 plus 16 times 2 is 32. So negative 4 times 4 is negative 16 plus 32, 16. So my vertex happened at 2, 16. And what is the max height the rocket reaches? It's in meters, so 16 meters. There's one part that I want to do for E, because I know it's going to happen. Some of you are not going to use the fact that the vertex is in the middle. You're going to want to complete the square when A is not 1. And I feel compelled to show you that. First, stop and think. Which one of these questions do you need the vertex for? Keywords you want to look for? Maximize. Maximize. This should scream out vertex to you. Should scream it. So let's complete the square of p of x equals negative 3x squared plus 30x minus 50. Let's find the vertex, because the vertex will tell me both of these. To complete the square, a has to equal 1. You still group your first two terms, and you make a 1. Therefore, you factor out a negative 3, because a has to equal 1. So you divide out negative 3 only in your first two terms. You're left with x squared plus 15x minus 50. You need to find your magical number. Your magical number that will help you complete this perfect square. So plus something minus 50 minus something. B is 15x. Sorry, B is 15x. I did something wrong. I know what I did wrong. 30x divided by negative 3. Whoa, I messed that up badly. This is negative 10. And I am 35 minutes into the video. No, I'm not fixing that. It's okay to make mistakes. We all make mistakes. What's important is that we catch them and we learn from them. So x squared minus 10x. So our new b is negative 10. So we have to find our magic number, which is b over 2 squared. Therefore, our magic number is negative 10 over 2 squared. Our magic number is negative 5 squared. Our magic number is 25. So we want to add 25. And this is what makes completing the square a little bit trickier when a initially is not 1. We have to subtract 25 times the original a. So we subtract 25 times negative 3. So to complete the square, we have negative 3 x. This tells us our sign, so minus square root of 25 is 5. Squared minus 50 minus 25 times negative 3 is a negative 75. Therefore, I'm minus 50 plus 75. So that's plus 25. If I'm looking at this, which is now in vertex form, my vertex is at 5, comma 25. This will help me answer maximization problems. Thank you for coming to my TED Talk. I hope you have a lot of success on your final. I appreciate you for watching this. I appreciate how much you care, and I'm sorry to stress you out. I promise you I just do it because I want you to learn, I want you to be better, and I want you to have the best chance at succeeding in mathematics. I love math. Thank you for watching. You're going to do amazing, I promise.